This section is just a further review of factoring. And in fact, in this section, when I was looking through it, it actually goes through the bottoms-up method. Whereas yesterday I talked about it, but they call it an algorithm if you read the text in this section. But if you look at the algorithm, it's the bottoms-up method. It's just an algorithm is just a process. If you use the process, you'll get the right answer. So the other two types of special three types actually of special factoring I want to talk about today are factoring by grouping, factoring like we do quadratics when they aren't quadratics, and I'll talk about that in a second, and then the sum and difference of two cubes, which I have on the wall. Okay, so factor by grouping, as an example, I'll just pick one here, 4x cubed plus 18x squared for help. Minus 10x minus 45. Factor by grouping only works when there's four terms. So if you ever see a problem on a test or a problem on a quiz or a problem on the ACT or anything like that that has four terms, you should always try factor by grouping first. And if it's not possible there, then we have to go into the more tedious process that we'll get into after we just do the normal factoring sections. Okay, but factor by grouping, you kind of split it into two groups. You've got 4x cubed plus 18x squared, and then the second group is negative 10x minus 45. We're going to look in the first two and see what's common to both. That would be, what, 2x? Everybody see that? And then this would become 2x plus 9, 2x squared. And then check it, 4x squared plus 18, or 4x cubed plus 18x squared. So I factored that right. Now I'm going to look at these. I can factor a negative 5 out, and I have 2x plus 9. Okay, you know it's going to work when your two parentheses are the same. If I forgot and I factored a positive 5 out, that's how it would have factored. Rather than saying they don't match, figure out what you might have been able to do to get them to match. Well, if I factored a negative 1 out here, this would have become negative here, and then they both match the same in the parentheses. Okay, so it's a little trial and error sometimes. So now what we do is we're going to factor 2x plus 9 out of both of these. I'm going to factor it out of this expression and this expression. Okay, so when I factor it out of the first one, I've got 2x squared left. When I factor it out of the second, I have negative 5 left. And now I've just factored that into two factors that will make it easier for me to solve this problem. Because now if I wanted to solve it, set it equal to 0, I could find both. I could find all the values of x that would make that 0. Whereas doing it like this, couldn't have done it. Okay, one thing you need to pay attention to, if you get down to this and this is factorable, you must factor it again. So if I got down to this and it was something like that, then I would say it's 2x plus 9 times x plus 3 times x minus 9. Okay, don't stop factoring if it's still factorable after you group. You want to try another one? Or are you feeling okay on factor by grouping? Don't all speak at once. Okay. Let's go 15x cubed plus 6x squared minus 10x minus 4. Okay, I can't factor anything out of all four. So now I'm going to look at four terms. I'm going to look at my first two. 3x squared, which leaves me 5x plus 2. And if I factor a 2 out, negative 2. And now I'm going to just pull the 5x plus 2 out of both terms. What I have left is 3x squared minus 2. And I can't factor anymore. Okay. All right. So another type of factoring you may see is something like this. Let me just do 2x to the fourth minus 5x squared. X squared minus 12. Okay, this is not a quadratic. This is a quartic. Its degree is 4 instead of 2 like our quadratics. But because it goes 4, 2, and then the constant, it is factorable like a quadratic. So I'm going to treat it like a quadratic and go ahead and multiply the 2 times the negative 12. Look for factors of negative 24 that add up to negative 5, negative 8, positive 3. This would be x squared. Then I'd still divide by 2, and that would become x squared minus 4, and x squared, 2x squared, plus 3. Not quite done. This is factorable. Okay, so my zeros, if I set this equal to 0, are 2 and negative 2, and then 2 imaginary. Right? If I set that to 0, I end up with the square root of negative 3/2, which is going to be 2 imaginary numbers. So it's going to be a quartic, a general quartic function looks a lot like a quadratic, except if it just has 2 zeros, it's a little flatter. It's not quite at an angle like that, but it's a little flatter at the bottom. If it has 4 zeros, it's going to do something like that. Quartic. So there's 2 kinds of quartics. There's either going to be 2 zeros, 4 zeros, or no zeros. A no zero quartic would have that long shape, but it'd be above the x-axis. Never crosses the x-axis. Okay? But it's factorable in the same way that we would factor quadratics. So if you can see that pattern, it's going to save you a lot of grief not having to do synthetic division or long division, which is coming next. Okay? If you can factor it, do that first. Okay? And then the last kind is the sum and difference of 2 cubes. So 27 is a perfect cube, 8's a perfect cube, x cube's a perfect cube, y cube's a perfect cube. So if I look at my formula for the difference of 2 cubes, it's a, same sign, a squared plus 2ab, right? No, just ab. I think I'd memorize this by now. Okay, so when you get it like this, until you really start seeing it, just identify A, identify B. What's A here?
Wait.
Be careful. 3x. And B is equal to 2y. So now I'm just going to plug A and B in my formula. Okay, so it's 3x minus 2y, 9x squared plus 6xy plus 4y squared. Once you get it this far, this will never be factorable. Don't even need to try. Okay, what ends up happening with these, there's 3 zeros possible, right? This ends up being your real 0. If I didn't have the y there, if it was just 3x minus 2. This ends up being a real 0. There's 2 imaginary here if you put it in the quadratic formula. So a difference of squares or a sum of squares only is going to have 1 0. The other 2 will be imaginary. But you can still factor it like this. Okay, so those are kind of more the advanced factoring techniques that we'll cover in this section. Factor by grouping, looking at the quadratic pattern, but doing it with quartics. You could also do it with something to the 8th. If I had changed this, but it would have to be 8, 4, and then the constant. As long as it's got that pattern, I could do it 6 and 3, 0. You can factor it like a quadratic even though it's not. Okay. And then the ones that don't fit any of these molds are the ones where we have to physically go to the effort of finding what the zeros are using synthetic division. Okay? All right.